Jill and Pat are both 35 years old and are both planning on retiring at age 65. Jill deposits $10,000 every year for 30 years into an account that pays a 4% annual rate of interest, compounded annually. Pat waits until age 50 to start saving, but then deposits $20,000 every year for 15 years into an account that pays a 4% annual rate of interest, compounded annually. And then in parts A and B, we want to figure out how much money each individual has in their account when they're 65 years old. A couple of things to notice about this account, or about this problem, is that both people, Jill and Pat, earn the same annual rate of interest, 4%. Additionally, they, over the course of however long, they deposit the same amount of their own money. Jill, you'll notice, deposits $10,000 every year for 30 years. So that's a total of $300,000 of her own money that she deposits. Pat, however, deposits $20,000 every year for 15 years. So that also works out to be $300,000. The main difference between the two individuals is the amount of time over which they deposit the money. For Jill, she deposits money over a period of 30 years. For Pat, it's only a period of 15 years. So actually solving this problem is not too difficult. It's very similar to what we saw in example 1. We're simply calculating future value. But this is a good problem to get to see an example of how to use the TVM solver in the TI-83. So first off, we need to access the TVM solver. Now, depending on what kind of calculator you have, you're going to do this in a slightly different way. If you have the TI-83, then right around here you're going to see a blue Apps button, and that's what you need to press. Once you click that Apps button, then you'll see a menu, and the very first option will be Finance, so you'll just hit Enter to select that. Now, that's for the 83 Plus. If you have the 83 or the 84 works the same way as the 83 Plus also. Now, if you just have a standard 83, what you do is you hit Second, and then this button here has Finance written above it. So I do Second, Finance, and the very first option here is TVM solver, so I select that. Okay, so now I need to fill in these variables to solve the problem. We will calculate Jill's future value first. So in this problem, or in the TVM solver, is exactly the same thing as what we call lowercase n. It's the total number of compounding periods. So for Jill, she started saving money when she was 35, and she saved until she was 65, so that's 30 years, and we are working on an annual basis, so n is 30. Then I click Enter. I% is the annual rate of interest compounded annually. So a couple of things to note here is that you always enter in the annual rate, and you always enter it in as a percent. So I type in 4, not 0.004. PV is the present value of the account. We're starting out with an empty account, so PV is 0. Payment is the size of the deposit. Now, one thing you need to keep in mind, on some problems, payment's going to be positive, and some problems, payment's going to be negative. The way to figure out which it should be is to put yourself in the position of the person and imagine if the money is coming to them or going away from them. In this case, Jill is depositing the money, so it is going away from her. For that reason, we make the payment negative. The payment is actually going to be negative for most problems we see, but not everyone. Okay, future value we don't know yet, so we'll come back to that. P over Y and C over Y. This is payments per year and compounding periods per year. These are always going to be the same for every problem we look at, and these are what we call M when we use the standard annuity formulas. So we are working on an annual basis here, so payments per year and compounding periods per year will both be 1. So now I'm ready to solve for future value, so I go up and highlight future value, and then I click this blue alpha button, and then I go down and hit Enter to click the Solve option. So doing that, this fills in the future value for Jill, which is $560,849.38. Okay, so for Jill, the amount of money she has at age 65 is $560,849.38. Okay, so now let's look at Pat. Now, fortunately, we can leave a little bit of this information in, although actually we will have to change most of it. He only saves money over 15 years. The interest rate is still 4%. The size of his payments are $20,000, so I do negative $20,000. And then payments per year and compounding periods per year are going to still be 1. So I highlight future value and hit alpha solve, and this tells me the future value for Pat. $400,471.75. So the answer for part B is $400,471.75. Okay, well, hopefully you followed that. If you want additional practice with the TVM solver, you can look at the TVM guide that I supplied. It'll be in the content folder under the notes on Blackboard. And then we will also see a few more examples involving the TVM solver.